Okay, welcome to our tutorial session. Today is February 6th, 2018, Tuesday. We will cover some R commands that you're going to need for the homework number 4. These are the topics that I'm going to cover in this session. Some linear regression model and finding the summary or the result of the linear model and things with residuals and some miscellaneous command such as mean and correlation. And then the last one is the linear model with some NAs. NAs meaning some no values within your data frame. So the first model, and before we start, it's always a good idea to set your directory, set your working directory this way. So set working directory and the location of the folder that you want to work with. Okay? This way. All right. So first one is a linear model. I downloaded one of the homework file in my directory. This way. And I mean, there are two ways or multiple ways you can pull the data into your data frame. One way is to import the data set, going this from Excel, and browse and find the file. Or the other way is to just type this command, read underscore Excel, quotation mark, and the file name. Okay. And run it. And then I have this data frame here. And I'm going to view this data frame with the command view. Okay. And I have this two columns, 17 rows with first column age in years and second column is price advertised in dollars. Okay. I usually change the column name just to make sure they're simple enough for that I can follow. So I go, the command is names for with your data frame with the C and age and price. Okay. And run this command. And then if I view my data frame one more time, the column name changed to age and price. Just this way is just for me, it's just easier to keep track the column names and stuff. The first command, or maybe you already have learned this command, is the plot, which creates a scatter plot. The first item that you put in the column is the x values, and the second one is the y values, and then these are the attributes to add the x label, y label, and the title name. Okay. If I run this and zoom in, a plot is created with the x-axis named as age, y-axis is price, and title age versus price. It's simple enough. And then what you want to do is try to run a linear model. So the linear model is what we want to make a prediction with some kind of a variable. So this the lm is a command that you need to use to create a linear model. The first item within the parentheses is the actually y value, or the number that you want to predict. So here you want to use the age to make a prediction for the price. Okay. So this is the value that you want to make a prediction, and this will be your x variable. Okay. And just add a tilde in between these two variables. And then run this. Okay, so I forgot to tell you. Whenever I put this sign, I'm adding or storing the model into some name. I just named it as a model. Instead of model, I can just put like model 2 or linear model, lin model like this. I'm just assigning a name to the linear model I'm going to create. Just keep it as model. Run this. An AB line model creates the best fitting line, which go across the data point in your plot. So if I run, it's called AB line. You add the model, the name of the model you made here, and you run it, and zoom in, a line is added to the plot. Okay. The summary command, and then parentheses, the model, will give you some kind of output of your linear model. Run it. So this is the output of the summary command, okay, which gives you residuals, the mean and the first quartile and median and so on, and the coefficient of your linear model. You know that in linear model you're making a prediction for the price. So if I write it this way, you're making a prediction of the price in terms of some coefficient, or the y-intercept, and then plus or minus the slope. I'm gonna put the just alpha, and times the x variable. Okay, I'm just gonna comment these out. So if you go back to the result, we have the estimates for the intercept and the estimate for the age. So this is the actually the parameter, or the slope of your model, which I put as alpha, and the intercept will be the y-intercept value. Okay, and these are the standard error and t-value, and then the p-value. Okay, if I pull down a little bit more, the one thing you should look at is the multiple r squared, which we know is just r squared, and adjusted r squared, and p-value, and f statistics. So these are the results that we get after we run the summary command of your linear model. So that kind of covers the first topic, and the second topic I wanted to cover on this session. The third topic that I want to cover is residuals. So residuals is what? You're making a prediction, and then there should be some differences in the actual number and the prediction. So residual will be the difference between the actual and the predicted value. So defining a residual is very simple. The command is residuals, and then put the parentheses, and then I'm adding the model, the linear model I created in previous line, and then I'm storing the residuals into some name resid. I'm running it, and then let's print the values out. Okay. Remember that we had the 17 values, and if the residuals are found with those 17 actual values. Okay. And then what we also want to do is to plot the residual versus x values. So plot is here the same. The order it comes is we're assign the x variable first, and then y variable. The age will be our x variable, and residual will be our y variable. And then we just add these attribute labels, y label, and then the title. Run it, and then this plot pops up. Okay. So what we also want to add a line that that crosses the zero value. We learned that before, which is we use the AB line. I think the first one is the intercept, I think, and then the second zero is a slope. So if we do this, we create a line that which goes through the 0 with the slope of also 0. Okay. So with this residual graph, we say that okay, the residuals are pretty much consistent for overall data. I mean, we can make an analysis with this residual plot. Okay. The other command you should know is the correlation command and then the mean command. So correlation command is pretty much simple. It's just a COR, and then the age is just x variable, and then the y variable. The order doesn't really matter. If I run this, we got the value for the correlation coefficient, which we know as R. So if you go back to the summary here of the linear regression we ran last time, I mean previously, we see that the multiple R squared is 0.8924. This should be equal to the square of the correlation value we found here. Okay, so I'm going to. We found that the correlation value is 0.9446 something, and I'm going to store this as an R. And if I square R value, then we get the same number as we saw in the summary result. Okay. Also, find the mean is also simple, just a mean command. And here we are trying to find the mean of all the prices, which is these values. So order is pretty much the same. We are this is the name of the data set, data frame, and then the $sign, and then we specify the column. Okay. The last one is the linear model with NAs, for example, no values. I mean, to explain this, I just added the one more data frame. I'm going to read this data to our R, and then if I run this, and then I'm going to view this model or this data frame this way. So it's pretty much the same, but then except for row 10 and row 11, there are two missing data. By mistake or no data, we don't know. So what do we do if we have this kind of missing values? Here, this line 40, I'm just going to assign the column names, just same column names I used before. And then I'm gonna run the regression with the data frame with the missing values. Okay. The command is the same, the lm. This is y value, tilde, and then the x value. Okay, I'm going to run this and then pull up the summary result of the linear model. So if you see that we notice that the multiple R-square value is different, which makes sense because there are two less data compared to the previous data frame you used. And we see that the two observations deleted due to missingness. Okay, so if you run the LM with the missing data frame, it just automatically disregards the missing values. So we had the 17 data points, but then here we have 15 data. So if we just use the LM and then run this regression, it just deletes the two data points and then just run a regression with the 15 data points. Okay. But then if you want to find the mean of this data with the missing values, if I run this, we get NA. So this is something different that we did when we had the complete data set. Okay. So what do we do when we have missing data and we want to find the mean? It's very simple actually. We can just add this NA in RM equals T, which means the NA remove true. So by adding this option or attribute, we are telling the model or telling the R to remove all the values with the NAs. Okay, if I do this, we get the mean. Okay. All right. I think that's it. That's pretty much it for today's R session. Thank you very much for listening. And bye-bye. Okay. Oh, how do I quit?
I unplugged it last time.
Hmm?
I unplugged the whole thing.
No, how do I quit the...
Yeah, you can't unless you unplug it.
Oh, really?
Yeah.